Good day to everyone. Let us discuss about geometric sequence. For activating prior knowledge, let us recall the ratio of a number. The ratio represents the number that needs to be multiplied by the denominator in order to yield the numerator. We have the following ratio worksheet. Simplify the following ratios. Number 1, 6 is to 10. 2, 9 is to 15. 3, 7 is to 35. 4, 10 is to 28. 5, 7 is to 7. 6, 12 is to 9. 7, 36 is to 20. 8, 24 is to 12. 9, 21 is to 56. 10, 28 is to 35. 11, 18 is to 15. 12, 55 is to 15. 13, 75 is to 6. 14, 11 is to 15. And 15, 5 is to 500. We may simplify this ratio numbers into logos or enjoy to simplify the following ratio. Our lesson purpose, the most essential learning consequences of this lesson was the learner determines geometric means and term of a geometric sequence and sum of the terms of a given finite or infinite geometric sequence. Let us have back the basic activity. Let us recall what we learned from the laws of exponents. When multiplying like bases, keep the base the same and add the exponents. When raising a base with a power to another power, keep the base the same and multiply the exponents. When dividing like bases, keep the base the same and subtract the denominator exponent from the numerator exponent. Number one, product rule. To multiply when two bases are the same, write the base and add the exponents. As you can see, we have the two bases, which is x raised to the n times x to the n power. We just copy the base and add the two exponents, which is m plus n. As you can see, we have the following examples. Example A, x to the cube or x to the third power multiplied by x to the eighth power. Then just copy the base, which is x, then add 8 plus 3, so we have 11. So our answer is x to the 11th power. While letter B, our common basis is 2. Just copy 2 and add the exponent, which is 4 and 2. So 4 plus 2 is 6. The final answer is 2 raised to the 6th power. In letter C, we have x and y is the common basis. The exponent of x is x raised to the second power, while the other is x to the third power. Copy the base, which is x, then add the exponent, which is 2 plus 3 is equal to 10. While the base y, we have y to the first power and y to the fourth power. Copy the base y, then add the exponent, 1 plus 4, we have 5. The answer is x to the fifth power times y to the fifth power. So this is the product rule. While the 2 is the quotient rule. To divide when two bases are the same, write the base and subtract the exponent. As you can see, we have x to the m power divided by x to the n power is equal to x to the m minus n. From the given example, all the examples are copy the common base and subtract the exponents. Number 3, we have zero exponent rule. When we encounter the zero exponent, the answer is always 1. The power rule, to raise a power to another power, just multiply the exponents. So as you can see, I give you 10 items to answer and apply the 4 laws of exponents. So simplify number 1, 3 times 4 raised to the third power. Number 2, 4x cubed times 2x to the third power. Number 3, x to the fifth power times x cubed. Number 4, 2x cubed minus 2x squared. Number 5, 6 to the fifth power divided by 6 cubed. Number 6, x to the fourth power divided by x to the seventh power. Number 7, 8 raised to the zeroth power. Number 8, negative quantity of 9x raised to the zeroth power. 9 times y to the fourth power raised to the third power. Number 10, x squared y raised to the fourth power. Or the quantity of x squared y raised to the fourth power. Next. For our unlocking content vocabulary, it says a geometric progression, also known as a geometric sequence. It is a mathematical sequence of non-zero numbers, where each term after the first is found by multiplying the previous one by a fixed number called the common ratio. For example, the sequence 2, 6, 18, and 54, so on and so forth, is a geometric progression with a common ratio of 3. The nth term a sub n of geometric sequence in which the first term is a sub 1 and the common ratio is represented by r is given by the following formula where n is any natural number. That's why we have the formula of a sub 1 is equal to a sub 1 times r raised to the n minus 1. We have the following first term, term to term rule. We have first 5 terms. So these are the examples how to apply the geometric sequence using the term to term rule. For your practice, so you may try this within 10 minutes. Find the next 3 terms, such as 128, 64, 32, 16, 8, so on and so forth. Find the ninth term of 0.01, 0.1, 1, 10, and 100. Find the seventh term, 1, 6, 36, 216, 1,296, so on and so forth. And number 4, find the 11th term, 1, negative 2, positive 4, negative 8, positive 16, so on and so forth. You may use the formula a sub n is equal to a sub 1 raised to the r raised to the n minus 1. So we have common ratio, we have the first term, and we are looking for the terms. Again, our formula for geometric sequence is a sub n equal to a sub 1 times the common ratio raised to the n minus 1. Yun lang. For the following geometric sequences, find A, which is the first term, or the unknown term, and R, and state the formula for the general term. So we have last term. So find the last term and R. State the formula for general term. Using the formula A sub n equal to A sub 1 times the common ratio raised to the n minus 1. Letter A, we have 139.7, 12.63, 1.5. And letter C, 9, -3, and 1. So R is equal to 3 is a common ratio for our A. And our formula for the general term is A sub n is equal to A sub 1 times 3 is n minus 1. While letter B, the common ratio is 1. Our formula for the general term A sub n equal to A sub 1 times 1 raised to n minus 1. While letter C, the common ratio is -1/3. Then our general formula for this term A sub n is equal to A sub 1 multiplied by -1/3 to the n minus. I invite Jamie Benuela to co-host in the send weekend box. Benedict Shumigo. Like, hello. Princess, good evening. Developing and deepening understanding, a geometric series is the sum of the terms of a geometric sequence. The sum of the first n terms of a series is denoted by S sub n. You can use either of the following formula to find the partial sum S sub n of the first n terms of a geometric series. We have the given A sub 1 and n, kung yan lang yung given sa problem, the formula that may use S sub n is equal to A sub 1 minus A sub 1 times R to the n power divided by 1 times R, which is R is not equal to 1. And if the given is A sub 1 and A sub n, the first term or last term, the sum of n is equal to A sub 1 minus A sub n times R, divided by 1 minus r. R is not equal to 1. Sometimes a sub 1 and a sub n or n must be determined before the sum of an arithmetic series can be found. When this occurs, use the formula for the n term. Find the sum of its geometric sequence. Letter E, a sub 1 is equal to 2, n is equal to 10, and r is equal to 3. By letter F, a sub 1 is equal to 2,000, a sub n is equal to 125, and r is equal to 1 half. Our formula for letter E, we have S sub n, or partial sum of the metric series, is equal to a sub 1 minus a sub 1 times r raised to the n power divided by 1 minus r. And while letter F, our formula is S sub n is equal to a sub 1 minus a sub n times r divided by 1 minus r. So distribute the given formula. We are looking to the partial sum of 10 is equal to 2 minus 2, quantity of 3 raised to the 10th power divided by 1 minus 3. S sub 10 is equal to 2 minus 2 multiplied by 59,010, which is 3 raised to the 10th power divided by negative 2. S sub 10 is equal to 2 minus 118,098 divided by negative 2. It becomes negative 118,096 divided by negative 2. So negative divided by negative is positive. That's why the answer of partial sum of the metric series is equal to 59,048. Jason Puerto Combat. Lloyd Edward. Again, for letter F, we have S sub n is equal to 2,000 minus 125 times 1 half divided by 1 minus 1 half. We have convert of 125 times 1 half. We got 62.5. Subtract 2,000 to 62.5 divided by 1 half. Reciprocal of 1 half is multiplied by 2. 1,937.50 times 2. The answer is 3,875. Or 3,807. For find the first term in the geometric series for which S sub n is equal to 13,116 and n is equal to 7, r is equal to 3, we have the given formula. S sub n is equal to a sub 1 minus a sub 1 times r raised to the n divided by 1 minus 2. Follow the formula and apply the data. And we will give the first term, which is try this problem. Find the first term in the geometric series for which S sub n is equal to negative 26,240, n is equal to 8, and r is equal to negative 3. For our lesson activity, determine if the sequence is geometric. If it is, find the following ratio. Test your understanding is the following sequence symmetry. Find the common region in the following sequence. And third, find the next frequency of the following sequence. For integrative activity for arithmetic sequence, we can use the modeling with sequence. And another one, we use geometric sequence, poles, and synonyms. Thank you for listening. The essence of mathematics is its freedom by George Factor. Thank you.